Welcome back to Daily Dose of Space. Tonight, we're not talking about rockets, astronauts, or distant planets. We're talking about something far more familiar: the night sky. For all of human history, the stars have been there. Ancient people used them to navigate. Civilizations built myths around them. Entire religions were shaped by patterns of light in the darkness above. And no matter where or when you were born, if you looked up at the sky on a clear night, you saw more or less the same universe. But that will not last. There will come a day when the night sky changes forever. Not suddenly, not dramatically, quietly, gradually, almost unnoticed. And when that change is complete, the universe we see today will be gone. Not destroyed, just unreachable. The sky we think is permanent. It's easy to assume that the night sky is stable. After all, stars barely move during a human lifetime. Constellations look the same generation after generation. Even across thousands of years, the sky feels fixed. But that sense of permanence is an illusion created by time. We live in a moment when the universe is old enough to be filled with stars, but young enough that we can still see far into it. When we look up, we're not just seeing nearby suns. We're seeing galaxies millions and billions of light years away. Their light has traveled for unimaginable lengths of time just to reach our eyes. In a very real sense, the night sky is a historical record. Every point of light is a message from the past. But what most people don't realize is that this view depends on timing, on the universe being in a very specific phase of its life. And that phase is temporary, because the universe is not static, it is expanding. And that expansion is changing what we can see. Right now, distant galaxies are moving away from us, not because they're flying through space, but because space itself is stretching between us and them. The farther a galaxy is, the faster it appears to recede. At extreme distances, that recession becomes faster than the speed of light. And when that happens, something strange occurs. Light from those galaxies can no longer reach us. They don't disappear in an explosion. They don't fade all at once. They simply slip beyond a boundary and never come back. The invisible wall around us. There is an invisible limit to the observable universe. It's called the cosmic horizon, and it defines the maximum distance from which light can ever reach us, even given infinite time. Anything beyond that boundary is not just far away, it is permanently unreachable. As the universe expands faster and faster, driven by dark energy, this horizon moves inward. Galaxies that are visible today will eventually cross it. When they do, their light stops arriving. The galaxy doesn't vanish instantly. Over time, it becomes dimmer, redder, stretched by expansion. Then one day, without ceremony, its final photons pass by Earth. After that, it's gone forever. And this is already happening. Right now, as you listen to this, there are galaxies whose last light is reaching Earth for the final time. No one notices, no alarm goes off. But the universe is quietly closing the door. This means something profound. Future astronomers will see a different universe than we do. Not because reality has changed, but because access has. And the farther into the future you go, the smaller the visible universe becomes. Which leads to an unsettling realization. Our era might be uniquely privileged. A sky that grows empty. Fast forward billions of years. The Milky Way will have merged with Andromeda, forming a single massive galaxy. Most other galaxies will have drifted beyond the cosmic horizon. To observers living in that distant future, the universe will look vastly different. They will see their local galaxy and almost nothing else. No expanding universe, no cosmic microwave background, no evidence of a Big Bang. The large-scale structure of the cosmos will be invisible to them. From their perspective, the universe will appear static, isolated, and eternal. In a cruel twist of cosmic timing, the very evidence that allowed us to discover the universe's true nature will no longer be observable. This means future civilizations could be surrounded by a universe that looks fundamentally simpler than ours, even though it isn't. They may never know how big the universe truly is. They may never know that billions of galaxies once filled the sky. Not because the knowledge was lost, but because the evidence disappeared. And this raises a haunting thought. What if intelligence can only fully understand the universe during a brief window of cosmic time? The end of the cosmic storyteller. Stars are not eternal. Over vast timescales, star formation slows down. Galaxies run out of the raw material needed to create new stars. Existing stars burn their fuel and fade. The bright, massive stars die first. Later, even sun-like stars exhaust their nuclear fuel. What remains are red dwarfs, white dwarfs, neutron stars, and black holes. The universe grows darker. The night sky of the far future will not be filled with glittering points of light. It will be dominated by darkness, punctuated by faint, long-lived stars that barely illuminate their surroundings. In that future, the sky will no longer tell a story of cosmic expansion, evolution, and origin. It will tell a story of endurance. And eventually, even that story fades. As entropy increases, usable energy becomes harder to extract. Structures decay. Complexity becomes more difficult to maintain. The universe doesn't end with an explosion. It ends with silence. Why this moment matters. We often talk about humanity as if we arrived late, as if the universe existed for billions of years without us and will continue long after we're gone. And that's true. But in another sense, we arrived at an extraordinary moment. We exist at a time when the universe is old enough to contain galaxies, stars, planets, and life, but young enough that we can still see the full cosmic landscape. We can observe the afterglow of the Big Bang. We can map distant galaxies. We can measure the expansion of space itself. That combination will not last. If intelligence arises too early, there is no structure to study. If it arises too late, the evidence is gone. We are balanced on a narrow ridge of cosmic time, and that makes this era fragile, not just technologically, but observationally. The most quiet disappearance. The most unsettling part of the story is how unremarkable it will seem while it happens. There will be no final night when the sky suddenly goes dark. No universal event that marks the end of cosmic visibility. Each generation will simply inherit a slightly emptier sky than the one before, a few fewer galaxies, a bit less light, a universe that feels just a little smaller. Until one day, the idea that the universe was once vast will sound like a myth. And that raises a final question. Are we meant to expand into the universe, or simply to witness it before it fades from view? The night sky feels eternal because it changes slowly. But slow change does not mean no change. We live in a rare moment when the universe still speaks clearly, when its history is written across the sky, in light that has traveled billions of years to reach us. One day, that conversation will end, not with a bang, but with a fading whisper. And maybe the most important thing we can do as a young species in a vast universe is simply to listen while we still can.